Okay, hello everyone. I'm going to go ahead and get started since we're on the top of the hour. Good morning. Welcome everyone to the May California Nevada DEWS Drought and Climate Outlook webinar. Thank you to those that have joined us previously and those that are joining us now for the first time. My name is Amanda Sheffield and I'm from Scripps Institution of Oceanography in San Diego, and I'm the Regional Drought Information Coordinator for NIDIS for California and Nevada. This is part of a bi-monthly webinar series that we've been doing all this year, designed to provide the region with the timely information on current drought status and its impacts, as well as a preview of climatic events, especially now that we've moved out of drought in the region. This webinar is being recorded, and it, along with presentation slides and a 2-page summary flyer, will be available on drought.gov later this week. Just a little background for those that are joining us for the first time. NIDIS is the National Integrated Drought Information System. They work to provide better understanding of how and why droughts affect society, the economy, and the environment. And this works to improve accessibility of this information for early warning and drought risk management. It builds off a network of regional drought early warning systems, including here in California and Nevada, to create a national drought early warning system. What is a drought early warning system? A little bit more, it uses new and existing partner networks to optimize the expertise of federal, tribal, state, local, and academic partners in the region to make this climate and drought science more available, including its impact data and making it more understandable and usable for decision makers. In California, Nevada builds off the original California DEWS, which started in 2010, and then with the addition of Nevada with its own impacts and information that was gathered during the Nevada Drought Forum in 2015. And a strategic plan has been underway for quite a bit of a while. We're moving towards moving that towards a more public area where we can see what we're up to and what we hope to accomplish in the next 2 years. Just then gets back to today's webinar. Today we're going to have the California Nevada Drought and Climate Status Update and Outlook per usual. Dave Simmerall from the Western Regional Climate Center is going to be providing the update, and Shrad Shukla, who's part of CNAP, will be doing the outlook. And then per the request from the last webinar, there's a lot of interest in wildfire potential for this year. So we have predictive services updates from Tom Rolinski in Southern California area, and Gina McGuire, who's going to talk about Nevada. With that, I'll go ahead and pass it over to our first presenter, Dave. Oh, and I'll remind everyone that we will be saving questions for the end. Go ahead and type them in the question box. If there's a quick one, we'll do them in between presenters, but we're mostly going to be doing them at the end. And go ahead, Dave.
Okay, can you see my screen?
Yes.
Okay, let me move this out of the way. All right, thanks, Amanda. My name is Dave Simmerall, as she had mentioned. I work at the Desert Research Institute and Western Regional Climate Center. I'm also a national author for the U.S. Drought Monitor. So I'm going to dive right in because I have quite a few slides here. See if we can get this to forward. Oops, there we go. Okay, so I'm going to start off, I'm going to take a look at the current drought status. Here's our latest U.S. Drought Monitor map as of last week. This came out last Thursday. And you can see across the west, most of the drought-related drought has been abated across the west. We've got some lingering areas in portions of California as well as in southern Arizona. Compared to a year ago, you can see on the left-hand side, this is the map from May 31st, 2016, and you can see I've got a little box drawn around it. Areas in the west that were in D1 to D4 drought were about 27% of the western U.S. On the right side, this is our latest map, and we're down to about 4% for the western U.S., so quite a bit of improvement. This is just another way of looking at it. This is a change map, and it basically, the cooler colors represent category improvements. So you can see we've had some really significant improvements since the beginning of the water year. Throughout California, we've had major improvements. You can see with the dark blue colors. This led to Governor Brown lifting the statewide drought emergency, except for a few counties in the San Joaquin Valley. This was back on April 7th, and we've had some major improvements in western portions of Nevada as well. So looking a little closer at California, left-hand side, so a year ago where the state was in 86% of the state was in D1 to D4 drought. And looking at the latest, we're down to 8% of the state in drought, with just a small portion in Southern California and southern end of the Central Coast, as well as the southeastern desert area of the state. Moving over to Nevada, same thing. We've got a year ago on the left-hand side where you can see 62% of the state was in D1, D4 drought, as compared to 0% of the state. So no drought currently within the state of Nevada. Taking a look at temperature departures from the beginning of the water year, California was generally near normal in northern portions to slightly below normal temperatures in the northern portion of the state, while Southern California was several degrees above normal. It's the same for Nevada as well. Most of the state was above normal in southern portions. We've had some below normal temperatures, departures in the northwestern part of the state. Looking at some of the shorter term conditions, on the left-hand side, last 30 days, right side, last 60 days, kind of near normal to slightly below normal in California. In Nevada, northern Nevada has been slightly below normal. Southern part of the state, kind of near normal. So how this year sized up, we've had a great year in terms of precipitation in both California and Nevada. Looking at some rankings, this is using our California Climate Tracker, and this uses data from the National Weather Service Cooperative Observer Network as well as PRISM data. So I took, this is looking at the precipitation rankings on the left-hand side of the last 122 years, and this is looking statewide for the water year for the last 7 months. This is only through April because we don't have data for May yet. So statewide, we're looking at ranked 121st out of 122 years in terms of wetness. It was definitely a wet year. The figure to the right of that, we're looking at it broken down by climate divisions, and these climate divisions are slightly different than the way NCEI at NOAA does them, but you can take a look in the upper right-hand corner for the breakdown of those regions. But you can see we've had record wetness in the Sierras, the northeastern part of the state, and northwestern coastal areas of the state, above average in the southern part of the state. Looking at mean temperatures, it was a warm year, but not a record year. It was 107th out of 122. And you can take a look at the breakdown on the right, definitely above average in the warmer in the southern part of the state than the northern part of the state. Looking at the record precipitation and atmospheric river trajectories, we had a number of atmospheric river events since the beginning of the water year. And on the right, you can see this is from a paper written back in 2015. And these are just some generalized trajectories of atmospheric rivers. But what you can see, looking on the left-hand side, this is looking at the water year October through April, and these are percentiles of precipitation. The dark green are areas where there is record precipitation, and you can see those areas within the Sierras, western and northern parts of the Great Basin, extending up into southeastern Utah and into western Wyoming. But you can see that they match the trajectories of the AR trajectories quite nicely. Looking at percentage of average precipitation from the beginning of the water year, you can see the colors on this map. These are percentages of normal, so the cooler colors and the purples are above normal, warmer colors below normal. California was well above normal across most of the state, especially in the northern portions and the Sierras. Nevada, northern Nevada was above normal. We had a couple dry areas within the state, kind of in the west central areas of the state and east central areas as well. There's a couple of time series plots that I put together from our drought tracker. On the left-hand side is temperature. This is mean temperature for the last 7 months, statewide in California. And you can see the overall trend has continued over about the past 6 years. We've been above normal in terms of mean temperatures. On the right, statewide, you can see we're way up there in terms of precipitation. And this is about the second wettest on record here. Looking at, most of you are probably familiar with the different index set of stations that the California Department of Water Resources uses. Looking at the left one, this is the Northern Sierra A Station Index. We've heard a lot about that this year. We had a record year, as you can see here. This is the wettest year prior to that in 82, 83. And looking back at here's the driest down here in 76, 77. So you can see we've exceeded the precipitation for the water year in that area. Also, looking at the San Joaquin Precipitation 5-station index, we're slightly below the wettest year on record. Moving further south, looking at the 6-station index, we're about the third wettest. So wettest on record in north central Sierra, second wettest, southern, third wettest. Looking at the shorter term, last 30 days, we've had a bit of a drying trend in the northern part of the state and California. That's expected this time of year as things start to dry out, but we have had some moisture in central Sierra and western Nevada, as well as southern portions of California as well. So looking at some of the climatological rankings, little difference in the figures I'm using here. This is using divisional data. We don't have the same type of tracking system for Nevada as we do for California with the California Climate Tracker. So this is, I picked out a couple that stood out here. This is on the top, Nevada Climate Division 1, which is the northwestern part of the state. And for the last 7-month period, this is beginning at the water year, we've got the wettest on record. And the one right below that is for the northeastern part of the state, and that's also the wettest 7-month period on record for those climate divisions. And I grabbed a couple of these are from the ASOS stations at Reno on the left, Elko on the right. Reno is in Climate Division 1 and Elko in Climate Division 2. And you can see this green area, this is precipitation. And this line here, this is the normal amount of precipitation. This is starting in January and moving throughout the year. As you can see, Reno is already at 11.15 inches. We've well exceeded our annual average precipitation. And that was back in late February that we exceeded that. Elko, well above normal as well, and they're on track for possibly breaking the record there as well if they have a good monsoon season. Here's some time series plots like the last ones I showed you for California. This is statewide Nevada. Same trend, warming trend over the past, above normal temperatures over the past 6 years. Precipitation above average as well. And taking a look at our river basin closer to where I'm at in Reno, Nevada. This is a Truckee River Basin. Same thing, you're seeing warmer temperatures in this area, and what really stands out here is on the precipitation, the record-breaking precipitation for the last 7-month period within the basin. Current snowpack situation, we're above normal as far as percent of normal for the day. To date, 195% of average in northern, 219 central, southern 168, and statewide 198%. This other map I took from the California Nevada River Forecast Center. This is the 7-day change in snow depth, so you can see the impact of the warming temperatures. You can see, you know, anywhere from about a foot to, you know, about 15, 16 inches of snowpack is melted in over the past week. I grabbed a couple. These were kind of interesting. This is a MODIS image from April 1st this year, and you can see the healthy snowpack across the Sierra Nevada. And this is looking at May 26th. You can see the melt off. Most of the snowpack is restricted to the higher elevations within the state. We have snow water equivalent here in the middle figure, and this is average snowpack temperature. And I just put this on because you can see this is snowpack is at, you know, around freezing, so that means you've got a lot of melting that's going on right now. Moving over to Nevada, same thing, we're well above normal across the ranges in Nevada. I just drove back from Idaho and got to take a look at some of the ranges driving back, and in northern part of the state, northeastern Nevada, and there's still quite a bit of snow up in the Rubies and Independence Range and Jarbidge, which is good news for runoff for the Humboldt River. This photo I took back in, this is late February, of the snowpack up on Mount Rose. This is the mountain range, or the pass that's just north of Lake Tahoe on the north end of it. So you can see we had quite a healthy snowpack and record snow levels up at the Mount Rose Snow Tell Station. There's a couple graphs of snowpack for the Walker and Truckee River basins. Black line on the top is this year, water year 2017. You can see they've well exceeded past several years. Same thing for northern and southern Great Basin. All those snowpacks are above normal, well above past several years. Moving along to soil moisture throughout the region. This is NLDAS, so this is modeled data, but it has observational data to put into the model. You can see in the Sierra Nevada as well as western portions of the state, northeastern portions of Nevada, as well as some portions within the Central Valley and Central Coast. We have very moist soils. We've had some lingering dryness and dry soils in the central part of Nevada that have been kind of hanging around there since last year. And this is kind of a reflection. There's other possible things that can play into this, but you know, this really shows how saturated the soil was. Last week there was a major landslide along Highway 1, kind of in between Big Sur and Hearst Castle. And this is about 45 feet of debris that's covered the road and blocked off Highway 1 in California. But that really just shows you how saturated the soils were along the central coast area of California. We're getting some kind of mixed messages here in that soil moisture. These are reports from the USDA as far as topsoil and subsoil moisture. We're seeing some areas in California, these are very generalized, but within California that we're seeing some dryness within the state. And I think some of that, I'm going to flip back, and we do get drying this time of year, but you can see how quickly, compared to April 1st, how some of these areas in the foothills and along the western side of the Central Valley are drying out pretty quickly. Looking at vegetative health, we use this at the U.S. Drought, the Vegetative Drought Index, VegDry. You can see very moist conditions throughout the Sierra and northeastern part of the state, and in general in Northern California, Western Nevada. That dryness and some of the soil moisture products is showing up in the vegetation as well within Nevada. And we have another vegetation index that we use as well, and you can kind of see the same, some of the drying areas in the foothills in California are showing up on there as well. Looking at the current stream flows, across the state, generally normal to above normal. We've got some rivers at flood stage at this point, and with the warming we've had, we're getting a lot of runoff. One of the issues at this point is making room in the reservoirs, certain reservoirs for flooding, for the amount of runoff that's occurring and avoiding potential flooding. Moving over to Nevada, kind of the same story, normal to above normal flows. We've got well above normal flows on the Carson and Walker, as well as Truckee River system as well. These are numbers from May 1st as far as reservoir storage. This is from NRCS. On the left-hand side, this is California's current reservoir situation. This is where, for May 1st, statewide, this is the average. So you can see we are now above average conditions in terms of percentage of normal. And Nevada as well, same situation. So we've made a really good recovery in both of those states. These are kind of some individual percentage of average for reservoirs as of March, or as of May 1st. You can see some of these are a little bit below normal. Those are areas where they're making room in the reservoirs for the runoff that's going to be coming off the snowpack, and they need to make room for that water to come into the reservoir. So they've been releasing quite a bit from those locations. Looking at the current California storage situation, as you can see on the latest figure for the major reservoirs, this is your historical average in the red. So you can see most of the reservoirs across the state are right at their average. Oroville, below average, and that's only because they're trying to make room within that reservoir for inflows. And as you know, they had some issues with the dam itself that they're working on. So it's not as much shortfalls, is not an issue this year at all with the snowpack and the amount of runoff. It's more the management of the rivers and reservoirs to avoid flooding is a major concern. And we've got a few lingering below normal reservoirs in the Santa Barbara area, as well as in Southern California, kind of in between Los Angeles and San Diego. This is a water storage tracking figure that Mike Dettinger from Scripps has put together, and this takes a look at both reservoir levels as well as snowpack, and looks at those two cumulatively. So on the bottom, this is our average from starting from October and going through July. These are the reservoir normals. So this is the total amount of acre feet for that period where it should be. Those are the normals for the 2000 to 2015 period. That's the average of that. This line here represents the reservoirs plus the snowpack. So what you see here in the yellow line is our current storage. So you see we've been above normal in terms of storage capacity in these 28 reservoirs. We're still above normal. And this is adding the reservoirs plus the snowpack. And this is tracking where we are. So we are well above normal. And as a reference point, here for April 1st. This is a critical date in which we look at where the snowpack is generally at its maximum. This is the wettest year on record in 1983 as a reference point. There's another wet year right below that with the orange triangle, 2011. So you can see we're in a pretty good situation coming into the summer, where we've got quite a bit in storage coming into the summer in terms of the snowpack. Moving over to Nevada. Nevada's made a really good recovery as well. Obviously, we don't have as many reservoirs as they do over in California, but a couple of our reservoirs were in really poor condition last year, particularly Lahontan and Rye Patch, which the Humboldt River feeds at. Both of those reservoirs have made significant recoveries, and Rye Patch provides water to farmers in Lovelock, and those folks down there are going to be getting full allotments this year, and in Fallon as well, which they receive water from the Lahontan Reservoir. And looking at Lake Mead, that's continued. That's a longer-term situation, and that doesn't look like it's going to make any recovery anytime soon. That's sitting at 36% of capacity. Looking at groundwater in California, we still have some longer-term issues with groundwater that you're seeing in the Santa Barbara area, as well as north of there, and as well as in the Inland Empire area. Moving over to Nevada, and there is more groundwater obviously within these states, but these are the wells that USGS monitors. We still have a number of wells in the Fallon area, as well as Carson Valley and Amargosa Valley, that are below normal. As I mentioned earlier, in terms of drought impacts, the governor has pulled back the drought state of emergency, except for several counties in the San Joaquin Valley. These areas currently are having emergency drinking water projects in place, so they didn't want to remove the drought emergency in those particular areas. Some other impacts we're seeing around the state, and these are kind of longer term ones to the ecosystems that we're seeing. A recent report of the USGS has found a number of dead tortoises in Joshua Tree National Park, and they believe this is linked to 5-year drought and lack of water within the park. This happens to be, which is kind of interesting. I do some field work in Joshua Tree National Park, and this was a desert tortoise at one of the monitoring sites I was at that I just happened to come across. So I thought this was kind of interesting. We've talked a lot about over the past year the tree mortality related to the longer-term impacts of the drought. These are the latest figures coming from the U.S. Forest Service, looking at tree mortality and the progression of such over the last several years. And you can see the high concentration of trees that are dying along the foothill areas in the kind of southern and central Sierras. So to wrap up, kind of take-home messages that California and Nevada have recovered quite well from the drought, in terms of this record-breaking winter in northern portions of the Great Basin, as well as portions of the Sierra Nevada. We've had significant recovery for California's major reservoirs, some lingering longer-term hydrologic drought impacts in southern portions of the central coast of California. And we're also seeing some cumulative impacts related to the drought in terms of forest health across the state. And that about wraps it up.
Thanks, Dave. As I said, we're going to save questions for the end, so I'm going to move on to our second presenter, which is Shraj Shukla from UC Santa Barbara. And he'll present the outlook.
Hey, Amanda, can you see my screen?
Yes, we can
And
see your
hear me
screen
okay?
and hear you. So go ahead.
Okay, great. Right. Thanks very much, Amanda, and thanks everyone for calling in. So, as Amanda said, this is Shad Shukla. I'm a researcher at UC Santa Barbara. And in this presentation today, I'll be focusing on
Brad, we lost your screen somehow.
what happened?
We just see the blank screen right now. We lost your PowerPoint.
How about now?
No, I don't see anything yet.
Okay. Huh. Sorry.
That's fine.
Let's see. Not sure why this is happening. Let's see. You still can't see anything?
Yeah, maybe just quickly take it out of presenter mode and just do it with the PowerPoint, maybe?
Okay. 1 second.
I'm guessing that's what triggered it.
Yeah, perhaps. Let's see. Does it show up now?
No. Here, let me quickly grab your slides.
Sorry, I don't know. Not sure what's happening here.
Let me take it back real quick and then send it to you and see if that works.
Okay.
Sorry, everyone. Technical difficulties.
Okay, can you see it now?
Yes.
Okay, I won't now go into presenter mode.
Sorry about
that. No problem. All right, well, sorry everyone. So as I was saying, in this presentation, I'll be focusing on drought and climate seasonal outlook. So mainly what this presentation will be about is current forecasts of ENSO, temperature, and hydrologic forecast for the coming season. Besides talking about the current forecasts of those variables, we will also look at the skill of those forecasts in hindcast over last 20, 30 years or so. So we can get a sense of how skillful these forecasts are. And I'll also provide links for where those forecasts can be seen. All right. So first one is ENSO forecast. Some of you may have already started hearing about potential development of El Nino later this year. So I thought it'd be useful to show what the current state of ENSO forecast is. So this slide shows the current official ENSO forecast. And the source of this is CPC and IRI. This forecast is released on the second Thursday of each month. And this forecast is developed using dynamical models, statistical models, and also human judgment based on the model performance and biases and so on. So on the left side, this figure shows the probability of development of El Nino, neutral ENSO, or La Nina starting from April, May, June season all the way through DJF of 2018. So if we just focus on the October onwards, which is the season that will matter most for our California and Nevada region, based on this forecast, this official ENSO forecast, it appears that the chances of El Nino development are not very different from the chances of neutral ENSO year. So as you can see on the right bottom, I have a table that shows the chances of La Nina, neutral ENSO, and El Nino development for OND 2017 through DJF 2018. So the numbers between neutral and and El Nino are pretty comparable. So based on this, currently there isn't a forecast for El Nino yet, but in this next slide, we're showing a comparison between the official product, which is shown on the left side, and the IRI objective forecast that comes from IRI and CPC objective forecast that actually is released a week after the official product, so on the third Thursday of the month. And the difference between these two forecasts are two mainly. First is the official forecast includes a human judgment component, whereas the objective forecast is solely based on the dynamical models and statistical models. And also, since there is a difference of a week between these forecasts, there could be some differences because of the changes in the initial condition of the forecast. So the point here is that the objective forecast as of May 18 is indicating that there will be about 60% chances of El Nino in fall and winter. So we'll have to keep an eye on this. And I think the next official ENSO forecast is set to come on June 8th or so. So we'll see what that forecast says. Also wanted to show a sea surface temperature forecast from North American Multi-Model Ensemble. For those of you who are not aware of this, it's basically a combination of about 7 to 8 models from different North American-based institutes in the US and in Canada. And the figures here show the forecast of SST for O&D season. And these forecasts were made in early May of this month. So on the left, this figure is showing the probability of above normal SST, and it's about 50 to 70% likelihood that the O&D temperature SST will be above normal. And in terms of the anomaly, if we use the ensemble mean, so that take the mean of all the scenarios generated by about 7 models, it appears that the anomaly is about 0.5 to about 2 degree around the Nino region. So one question will probably come to most of you's mind is that, well, how does this forecast compare with the forecast made at this time, but 2 years ago when we experienced a very strong El Nino? So on the left is the forecast generated in May 2015 for O&D 2015, and on the right is the forecast generated in current May for O&D 2017. And as we can easily see that the forecasted anomaly in May 2015 was much, much stronger than it is right now. So based on this, I mean, I think it's safe to say that we are likely not going to experience any such major event as in 2015-16. So finally, another question we may have is that, well, how skillful are these ENSO forecasts? So here I'm only showing the forecast skill for NMME models and how well they forecast ENSO. So there are actually 2 new studies that have come out in last month or so. So first one on the left shows the skill of multi-model ensemble. So taking the, again, ENSO forecast from all the models. So it's skill in terms of deterministic score using ensemble mean. So again, if we focus only on O&D and JF, which are our rainfall season months, it appears that the skill of ENSO forecast for these target months is pretty promising. And the dots here show the statistical significance of the skill. So even starting from October, these forecasts are skillful about 6 months or so in advance. And the same story is true for probabilistic skill score as well. The point here is that NMME and so forecast is skillful for the late fall and winter season months. So now moving on to temperature forecast quickly. So here on the left, I'm showing the CPC temperature outlook for the entire US. On the right, I'm showing the same, but using only NMME models. The key message here is that for JJA season, the probability of above normal temperature in California and Nevada region is about 40 to 50%. There is parts of Southwest that includes parts of California and Nevada where the chances of abnormal is slightly higher. We see the similar pattern in NMME forecast as well. And again, if we use the ensemble mean, the expected anomaly of temperature is somewhere between 0.5 to 1. So now also taking a look at the JAS temperature forecast, similar stories. The only difference is that now for a greater part of the California and Nevada region, the chances of above normal temperature is above 50% or so now. Same pattern we can see in NMME forecast as well. And again, the expected anomaly is about 0.5 to 1 degree as of now. So now, again, well, how skillful are the temperature forecast at this time of the year? So here we're showing two figures that show the skill of JJA temperature forecast on the left and JAS temperature forecast on the right. And these both of the forecasts are generated in May. So they are comparable to the forecast that I just showed. So in this figure, the darker green color and the purple kind of cyan color show higher skill. So we can easily see that over California and Nevada, especially in the interior parts, not so much in the coastal regions, these forecasts are indeed skillful. So based on this forecast skill and the fact that currently the forecast is for above normal temperature, I think it's reasonable to assume that there will be above normal temperature in the upcoming season. Now, again, another interesting thing I wanted to highlight is that if we focus on not the only the seasonal scale forecast, but the forecast of temperature event during each month, what we are finding is that if we use NMME models, all the NMME models, the skill of forecasting temperature for the month of June and July is consistently higher, starting from April or so of the year. So again, point is that the forecast that we are NMME is producing is likely skillful. Now, finally, moving on to hydrologic forecast. So starting with water supply outlook, that basically is generated in terms of stream flow volume that is expected to pass a point of stream during spring and summer. And these forecasts are available from NRCS. And the forecasts are based on statistical model, and they use mainly predictors like observed snow water equivalent, and also in some cases precipitation and antecedent stream flow. So as Dave had already shown, snow-tail observation already show that the snow on the ground is much above normal. So it's well expected that because of the higher snow, the likelihood of stream flow volume being above normal is also very high. And since, again, it's not a news for most people that since it doesn't rain much during the summer season, it's the antecedent snow conditions that control most of the stream flow volume later in the season. So hence, these forecasts are actually very skillful at this time. Another thing I wanted to highlight here is these are the same sort of figure showing water supply outlook for spring to summer, but these forecasts were made from February, then March, then April, and May. And as you can see that since February 1, for much of the California and the Great Basin, the forecast was for above normal stream flow volume. So it's been consistently for above normal stream flow, and of course based on the snow condition. Now, finally looking at the skill of the water supply outlook. So I found this very nice paper from Pagano et al. In 2004 that uses about 22 to 29 different sites from NRCS to look at their historical skill. And on the left, the figure is showing the skill in terms of correlation. So the darker, the solid black circles show the higher skill, and the size actually denotes the skill. So a smaller size of black circle means less skill, and so on. So as you can see, in most of the California and Nevada sites, the skill is a skill of April 1 forecast of water supply is pretty high. Now, finally, just wanted to show soil moisture forecast. And the difference between these forecasts and the forecast that I just showed is that these soil moisture forecasts are more dynamical in nature. So they are generated using by forcing a hydrologic model, in this case a WIC model with CFS version 2, which is one of the climate model used in NMME forecast. So that this a soil moisture forecast does incorporate the temperature, for example, that's been forecasted for upcoming season. So we can see that the forecast for soil moisture for June, July, and August here, and in most cases, it appears that over California and Nevada, there is a good chance of above normal soil moisture percentile. And there are still some regions where there is chances of below normal soil moisture. And I think they may be the same regions as the region that Dave highlighted in his presentation. So in summary, official ENSO forecast is for ENSO neutral state. Objective ENSO forecast indicate higher chances for El Nino development this fall or winter. We need to keep an eye on this and see what the next forecast indicates. Historically, NMME ENSO forecasts have been most skillful for fall and winter target months, up to about 6 months in advance. Above normal temperature is likely for California and Nevada region during JJA and JAS season, and historically, NMME temperature forecast is skillful for those seasons, mainly in interior parts of California and Nevada region. Above normal, about greater than 130% of normal water supply outlook is expected, and historically, these forecasts are skillful over California and the Great Basin region. So with that, I'll just leave these different web links from where I got these different forecasts if someone wanted to make a note of it. Thanks very much.
Great, thanks, Rad. At this time, I'm going to move over to Gina McGuire from BLM. But before that, Tom, he's our next speaker after that. Tom, are you online?
Yeah, can you hear me?
Yes, we can. Good.
Can you hear me?
Yes.
Okay, you can hear me? Great.
Yeah.
Okay, I'll just wait till Gina finishes and we're ready to go.
Yeah, great. Glad that's working now. Gina, there's 2 of you online right now, so I wanted to pass. If this one works, let me know.
Oh, okay. Let me see if it works here.
Did it share over with you?
I don't see anything yet. Oh, wait, hold on. There's something popping up. Let me see. I don't think so.
Okay,
maybe
let me
try
try
the other one.
For some reason, there's 2 now.
Okay, there we go. Now I got to show my screen.
Great. And we can see, so you're good.
Okay. Well, good morning, everyone, or almost good afternoon now. I am Gina McGuire. As Amanda said earlier, I am a meteorologist for the Great Basin Predictive Services staff. The Great Basin Coordination Center is located in Salt Lake City, but I work out of Reno, Nevada. So I largely support Nevada, but Nevada is a small part of my area of responsibility, if you can call it that. And it's part of the entire Great Basin, which is Nevada, Utah, the southern half of Idaho, and western Wyoming, with a very small part of California, generally south of the Tahoe Basin and the Sierra. at least in the Sierra Nevada foothills. So kind of a big area of responsibility, but my main role is to provide weather forecast information and fire potential forecast information for the Great Basin to aid in decision-making of resource movement and just kind of anticipation of the overall fire season and what to expect as we get into the operational fire season, which we are just starting as of right now. So I'm a little bit more operational based as we go through the summertime. So that's kind of my background. I'm going to go through some images, just kind of our past winter, which have largely been already showed. So some of these will be a repeat, which means I will go through them extremely quickly. And then just get to kind of the fire season for mainly focusing on Nevada for this call. And then I know Tom is going to talk a little bit about, obviously about California, but also a little bit about predictive services as a whole and just a little bit about our program. So you'll hear a little bit more about that with Tom. So with that, I'm just going to go ahead and go on with the update for Nevada. So hopefully you're seeing my screen, which shows the water year precipitation since October 1st for the western U.S. And again, this image has already been seen, so we know that precipitation has largely been well above normal over much of the west. And for Nevada, that means generally the northern half and western half of the state, where southern, central, and eastern areas did not fare quite as well. But even for southern and eastern Nevada, when we see normal amounts of precipitation, that's usually a really good winter, especially for southern Nevada, who largely gets kind of removed from much of our precipitation in the state the majority of the time. So obviously the main focus of the precipitation over the winter was over the western and northern side of the state. The next slide shows what we've again already seen, the percentile, our record wettest precipitation for the October-March period, and obviously showing that record moisture over the Sierra into western and northern Nevada, and then much lesser as you go further south into the southern portion of the state, and again, mainly near normal down in the south, but there were some areas that did see slightly above normal. The snowpack map, again, we've seen this already. We know we're largely well above normal in all of the west, so we're still dealing with that. So as we go through the next month or two, we will continue to see the gradual melting of the snowpack, and also those flood concerns that have already been mentioned. Are the main concerns for Nevada are along the rivers and creeks, mainly the Humboldt, possibly parts of the Truckee, but mainly more smaller basins on the western side of the state, just with all that moisture. So this map from the NRCS has already been shown, but I don't think for the upper Humboldt River. So I'll look at the upper Humboldt and also the Carson, which is representing mainly the northern and western side of the state that got all that moisture. So this one for the upper Humboldt, showing the snowpack summary, you can see the years in reference are mainly 1984, 2005, 2006, and the current year, along with the median. So looking at the current year, the year in black, obviously above normal with relation to that area of the state, but looking at some of our big years, 1984 and even 2006 to some extent, generally below that as far as a snowpack in those areas. So we did have quite a bit of moisture, but as far as the snowpack is concerned, definitely quite a bit less than some of our historic years. The next slide shows the Carson River Basin. So this is really most of the precipitation in the state fells on the western side. So we obviously did see record wetting, as you saw from the map earlier. Also, we saw our wettest January in parts of western Nevada on record. So quite a bit of moisture, and looking at these years of reference, 2011, 1995, and then 1983, which was our biggest year, showing just well above most of those years and kind of tracking with 1983 for quite a while. And then obviously did pop a little bit above that as we got into the last couple of months. So again, very wet. So now that we look at sort of the precipitation and what fell, now we'll move on to the fire side of things. And the fuels are a huge part of fire behavior, fire activity across really in any area. And the precipitation will lead to how those fuels enter fire season and also how they change as we go through the fire season. So first, I'm going to go from the larger fuels, which are the 1,000-hour fuels, think timber, really large diameter fuels, kind of the largest fuel category. And so this is kind of showing more of the forested areas. And looking at this map, most of the colors in Nevada are in that yellow or oranges category, 6 to 15%. But as you get more to the areas bordering Idaho or bordering California to the west, and you can see we're above still that 15 to 20%, which is again where that deep snowpack is still residing and will continue to. So it will take a while before these 1,000-hour fuel moistures really start to come down into critical levels, at least in our higher elevations. And then we don't have obviously those large fuels in the lower elevations. So this is mainly showing our forested areas. Now looking at 100-hour fuels, we're getting a little bit smaller, more sagebrush fuel moisture, kind of that middle of the road fuel diameter, which is a large portion of our fuels in Nevada next to grass. You can see generally the driest areas are in that southern area of the state, which is expected due to, as we saw earlier in the presentations, the moisture in the last couple of months has really been reduced over the southern half of the state, and it's really been seeing this warmer, drier trend on there. So seeing the lower fuel moistures is definitely expected. And then as you move further north and west, they get a little bit higher, and then as you get up into the Sierra, they get higher even so, which again is expected. But we're kind of in this 6 to 10% range, which is above normal for this time of year, but we will start to see those fuel moistures really start to come down here in the next month. Now looking at 10-hour fuels, which is getting much smaller in fuels, our grasses, which are really the main driver for our fire season as far as fire spread in Nevada, are 1-hour fuels. So this kind of gives you an idea of, fuel moisture is a little bit larger than what we would see in the grasses. But as we get smaller in fuels, obviously those fuel moistures will be decreased. So we're in that 3 to 4% range, really across most of the state, a little bit higher up north and west, and a little bit lower down in the far south. But again, that's just showing that drying trend that we've been seeing here over the certainly last couple of weeks, and in some areas of the state in the south has been longer than that. So we've kind of looked at sort of our past weather, our fuel moistures, which is a very small piece of the puzzle, I think, to looking at the fire season. Obviously, fuel dryness is very important. If we don't have dry fuels, the risk of large or significant fires is minimized. However, some of the bigger pieces of the puzzle are going to be fuel loading, which is how much grass and how much fuel we actually have out there, and continuity, which is how widespread those fuels actually exist across the state. So for Nevada, and this is different depending on which area of the country you're in, we are largely a BLM state. We have mostly low to mid elevation fires. We don't have a lot of timber fires, so grass is what really drives our fire season in this state. So when we see the real wet winters, in some cases, we will get a large grass crop, which could lead to a big fire season. And I'll talk a little bit more about that here in the coming slides. So first, this is, we've seen kind of the CPC outlook for the weather or the temperature and precipitation here coming up over the next few months. This outlook is put out by the Predictive Services staff, and it just kind of breaks everything down by month, looking at kind of the same type of things I'm sure CPC looks at, but just a little bit differently. And some of our outlooks are slightly different from what we would see from CPC, but this is kind of just another angle to look at weather and precipitation across the country for the next 4 months. So for May, we've largely been, for the West, looking at warm temperatures, dry conditions over the southern half of Nevada, and that's really how it's worked out across much of the area throughout the month of May. And then as we go through June and July, we're probably seeing a better chance of dry and warm weather on the northern and western fringes of Nevada and going more into the west, as opposed to the eastern side of the Great Basin and the Four Corners area, which is where the monsoon really should start to evolve here as we go later in the month of June and into July. So we are expecting that more traditional monsoon track where it stays over the central and eastern portion of the basin into the Four Corners area, and then potentially extends a little bit further north this year up into parts of Idaho and Wyoming, and still keeping the western and northern side of Nevada kind of on that drier, warmer side. So one thing that I've kind of been looking at over the last year or so is looking at drought, and this is the drought time series from the year 2000 when the drought monitor began all the way through the current year. And this, I was interested because in Nevada, we always hear we've had a big winter, we're going to have a big fire season, or we've had a dry winter, we're going to have a big fire season. And both of those have been true. So I try to look at things a little bit different as far as weather elements. And I started looking at drought, and I thought it was really interesting that for when drought seems to be a real terrible word, and we hear it a lot. Obviously, we've been in drought for the last 4 years, and there's always been this risk of, are we going to burn a lot of acres? Are we going to have large fires? Where is the threat? And so I started looking at the way drought related to our fire seasons. And this is just looking at Nevada BLM fires, which is generally that low mid elevation, looking at grasses, sagebrush, kind of where our main fires usually are located. And across the bottom of the time series, I have all the years from 2000 on the left all the way till 2018 on the right. So pretty much last 16 fire seasons. And it was, I wouldn't say it was surprising, but it was interesting to see where our big years fell within Nevada, meaning what years we burned above normal acreage across the state, looking at the maybe 20-year average as far as acres burned. So our big fire seasons here in Nevada were 99, which is not on this map because there wasn't a drought monitor at that point, 99, 2000, and 2001, and then not again until 2005, 6, and 7, and then 2011 and 2012, and then here we are in the current year. So I found it interesting that all of our years where we had any type of significant drought were not big fire years for the state of Nevada. It's usually the years in between where it's either the shoulder seasons where we're coming into drought or coming out of drought, or we're deep in the middle of having no drought. And that makes sense when you think about Nevada as a whole, as far as where most of our acreage burns come from. And it's usually grass, it's usually in grass areas. If we don't have a grass crop, we're not going to get large fire because we don't have the continuity of fuels to carry the fire from one point to another. So we really need that in Nevada to have a big fire season, which is kind of where we've been coming out of. Last year we saw our acreage burn really started to go up. It wasn't above normal, but it certainly was right on the fringe of normal, which was a lot more than what we had seen the previous 4 years where we were in this deep state of drought. So that's kind of what I looked at coming into this as another indication of where our fire season might be. And when I looked at Forest Service lands, I kind of I didn't put that image in here because I wanted to kind of keep the constraints of time in the back of my head, but I expected a different trend. I expected, looking at timber fuels, larger fuels, that we would see our big years where we've burned a lot of acres in the timber areas in years where we had significant drought, and that just was not the case. Most of our, all of our, within the last 16 years, all of our years where we burned above normal acreage in either Nevada Department of Forestry or Forest Service lands was on our shoulder seasons of drought. We didn't have any big fire seasons in these middle years, 2002, 3, 4, 8, 9, 10, 13, 14, 15, 16. All those years where we were deep in drought, we did not have big fire seasons. It wasn't in years that we had no drought, but it was kind of where we were entering or exiting drought. So again, we still had some effects of drought in the larger fuels to deal with, but we also had grasses that extended further up in elevation than we would consider normal, that we wouldn't see in a normal year. Similar to this year, we have not only continuous grass crop in the lower elevations, we're seeing grass extend up higher in elevation than what we would normally see. So that's going to be a carrier of fire to these mid and higher elevations that maybe normally wouldn't see that. So again, that's just another indication of sort of where we're going for the fire season. So that leads into our fire potential outlook, and these are national outlooks. Each geographic area puts out their own outlook, and then it's combined to produce one national map. So again, for my area, I'm the Great Basin, so I cover Nevada, Utah, southern Idaho, southern and central Idaho, and western Wyoming. And you can see from the maps, the top left map is for the month of May, so we're obviously now just getting out of that month. Generally below normal, we were expecting for all the high elevations, and that has been the case. We haven't really, obviously seen any activity just because of the snowpack. And then generally normal in the other areas of Nevada, both for May and June. And that has been the case. May, we started to see some fire activity pick up. We'll probably start seeing more fires, at least in number. And then as far as acreage, that's going to depend on the weather. As soon as we come out of hot, dry periods and we have a little bit of wind, if a fire starts where we have significant, tall, continuous grasses, it's going to spread. And that's going to be an issue as we especially go into July and August, when not only the grasses are curing, but also we start decreasing our fuel moisture in the higher elevations, our soil moisture will go down, and our sagebrush and other fuels will become critically dry, and then we will have all fuels available to burn, in addition to the significant grass crop is really where our problem areas are going to be. And you can see that from the map on the lower right, showing generally the northern and western half of the state will definitely be an issue because of the grass crop. Not to say that we will not have fires in other areas of the state, but probably see some more normal activity, meaning that fires, we could have some large fires, but once we get into July and August, the monsoon should really start to kick in, and that should decrease our chances for significant fire problems over the eastern and southern third of the state at least. And then depending on how far that moisture pushes to the north and west will determine what part of Nevada kind of gets cut off from that from the significant fire potential depending on the dryness. So we're looking at a pretty significant season here as we go into July and August, again, for that northern and western side of the state because of those lower elevation grasses. So that's all I had as far as my portion of the presentation, and I'll turn it back to Amanda.
Great, thanks, Gina. I'm going to pass it over to Tom now. Tom, am I sharing the screen with you, correct?
Yes.
Okay.
And
you'll get a little message there. While we're transitioning, Gina, there was one quick question for you. How the major fire years in Nevada track with temperature anomalies, not just drought necessarily? Do you have a quick answer for that?
That's a tough one for Nevada. We've had significant fire seasons where temperatures have been near normal or at some points below normal, and then we've had ones where the temperatures have been well above normal. So it doesn't seem to have a good correlation with, whether we've had a hot, and I'm assuming they're talking about during the fire season temperatures and not during the winter time. Mm-hmm. It does not seem to have a good correlation. I mean, we always get hot and dry enough in Nevada typically to have significant fires. That's usually not an issue for us being a desert. But as far as how they relate to normal, there hasn't really been a good correlation that points. It's more really the fuels are, I would say, the biggest determination of whether or not we have a fire season. We need to have grass, they need to be continuous, and then after that, they need to be dry enough. I mean, because we've had summers, probably, I think it was 2 summers ago, where we had several remnant tropical systems move off, and we basically got soaked from July through August and had no fire season because we were really, really wet. And so it's really the moisture is a bigger player than the temperatures. And then those fuel conditions and really what's available to burn. Because we could be hot, extremely dry, but if we don't have that grass growth from the previous 1 or 2 wet winters, then we might have a lot of single tree starts if we have starts, but they're not going to go anywhere if we don't have the fuels to carry it. So yeah, temperature is not a very good one to determine fire activity. Obviously, it plays a very important role in the weather that affects if a fire starts, where it may go with everything else.
Great, thanks, Gina. And now I'll pass over to Tom, who's in the California region instead of the Great Basin. So go ahead, Tom.
Okay, thank you. Can you see my screen?
Yes.
Okay, great. Okay, so I'm going to switch gears a little bit here and just talk real briefly about predictive services, just kind of give folks an idea of what we do and some of the products we produce, and then I'll get into our seasonal outlook towards the end here. I know a lot was already talked about of course, with the drought and water supply and Gina going over her area, so I don't want to be too redundant, but let me just kind of talk a little bit about predictive services. For those folks that are not familiar with predictive services, we're a national program and we operate out of the geographic area coordination centers throughout the United States. I'll talk more about that in just a second. But predictive services is comprised of meteorologists, fire intelligence coordinators, and in some cases, fire behavior analysts. Here in California, we have a fire behavior analyst up in Redding at the Coordination Center in Northern California. Predictive services combines weather, fuels, and resource availability to provide more of a comprehensive look at fire potential, meaning where and when largest fires will occur. So we're, even like Gina and I, we're meteorologists. We're not forecasting the weather as in the same sense as folks from the National Weather Service would be doing, but what we're doing is we're combining weather information with fuels information, and Gina talked about the fuels a lot. They're extremely important in terms of our fire potential and our what's going to be happening with our fire season, and then what kind of resources we have available. We're looking at all that information to put together these comprehensive products that talk about fire potential, fire danger for our particular region. So that's a really unique thing with that Predictive Services does, which is very different from what the Weather Service does. So just kind of give you an idea here, the map on the right showing the predictive service, or I should say the geographic areas, the coordination centers, which basically are responsible for the mobilization of shared fire resources within their area of responsibility. And we have 10 coordination centers across the country. By the way, Alaska is further north. It's not off the coast of California there, and Hawaii is a little further to the west there. But so Gina, in the Great Basin, you can see her area there. So she was talking about Nevada, but again, her area extends further north and east to cover parts of Utah and Idaho. And California is unique. We have 2 geographic area coordination centers. It's the only part of the country that has, most coordination centers cover multiple states. We actually have 2 coordination centers in California, the one up in Redding, and then here in Riverside where I work. So that's pretty unique, and it kind of gives you an idea of the kind of fire seasons we have here in California. And then some of our products, these are just a couple of our products. I didn't want to spend the time going through all of our products here, but given that we're talking about our seasonal outlook here, we produce a monthly seasonal outlook. We update it every month, the first of each month, and it's basically a 4-month outlook. We talk about weather, fuels, fire potential, and usually it's 2 to 3 pages long with some supporting graphics, but we'll highlight our areas of concern over the next 4 months. And we do this with whether we're in fire season or out of fire season. So all through the year, we're updating this every month. So it gives folks a good idea for what we can expect throughout the year. We also do a webcast, which I encourage you guys to take a look. I know Gina does one as well. Most of the GACs, most of the predictive service areas or units do a webcast. This is about a 3 to 5 minute briefing on weather, fuels, fire potential, audio, visual, little kind of a movie clip that you can download. You can watch it on your iPhone. You can watch it on your PC as well. But people find this really helpful, just kind of get an update on what's going on. Right now, we're doing this Monday through Friday, and I think most of the predictive service units are doing that as well. And it goes out for about 5 to 7 days. So I'd encourage you to check that out. And this is our web page, which all the geographic area coordination centers have their own web page, and they have a predictive services section. We have, and each predictive services section is a little bit different, but we have a lot of information on here, and I won't go through all that. The best way to get to our web page is just to type in gacc.nifc.gov, gac.nifc.gov, and that'll get you to the kind of the overall, the general national site, and then from there you can go to each of the geographic area coordination centers for the specific areas. Okay, so before I get to this, I wanted to, Gina was, so anyway, that's a little bit about predictive services, and then I wanted to just briefly talk about our fire season here. Again, a lot of things were already mentioned, so I don't want to rehash that. One of the things I did want to kind of reiterate is the fact that is about our fuels, and our fuels are extremely important. They drive our fire season. It's not just enough to look at dead fuel moisture or live fuel moisture, but there's basically, the way I kind of describe our fuel conditions here in California and really anywhere, is there's really 3 major components to our fuels, and that is, in terms of fuel moisture, I should say, and that is the moisture content in the dead material, the moisture content in the live material, and then the annual grasses. And all 3 of those things can be in phase or out of phase with one another, depending on the time of the year and depending on the weather situation. So, you know, there's times of the year where, particularly like in the late summer, early fall, where our dead fuel moisture is very low. If we get into an extended period of hot, dry weather, by that time, all our grasses have cured out and are ready to burn. And then usually our live fuel moisture by the end of September, early October is very, very low. And obviously that's kind of the time when we start getting into our Santa Ana winds here in Southern California. So that's always a critical time in our fire season, at least in Southern California, comes to a climax around that time of the year, just because everything's sort of in alignment in terms of what the fuels are doing. And then we have, you know, if we have any kind of critical weather event like Santa Ana winds, obviously that's a major concern to us. And then Gina also mentioned about the fuel loading and the fuel continuity. But one of the things I wanted to show real quick here on our website is this is, and Gina went over this, this is 100-hour dead fuel moisture. So this is dead fuel moisture and sort of the bigger types of fuels, not necessarily the timber, but kind of the heavier brush. And what's interesting, this is a particular area along the central coast of California that you're seeing. We've had a lot of fire activity there recently, a lot of grass fires. In fact, one fire was over 10,000 acres here just recently. So we're getting a lot of fire activity, but the key thing is right now it's burning in the grass. And while these fires can get quite large and they burn very rapidly, they usually don't, at this time, they're not getting into the heavier fuels. And the reason for that is the dead fuel moisture in the heavier fuels is still pretty high, and that's indicated by the blue line there. The red line is the maximum, and the gray line there is the average. So basically, our dead fuel moisture in the heavier fuels is really right around average, or even slightly above average. So while we're seeing a lot of grass fires, we're not seeing these fires carrying into the heavier fuels at this time. Now that's going to change as we get later into the fire season. So I just wanted to show you that really quickly. And then the other thing I wanted to show you is we're in the process of updating our fire potential maps here. I know Gina was kind of showing what we currently have out. This is kind of you're getting kind of a preview of what we're going to have out here in the next 5 days or so, or actually next couple of days, with June 1st showing the new outlook. But anyway, this is the outlook for Southern Central California for June and July, showing those areas in above normal, mostly directed towards the grass situation where we're having a lot of grass fires. That's going to continue for the next couple of months in the lower elevations. Those grasses are all cured out. And really during hotter, drier conditions, and then if we have any kind of wind events here, that's usually when we start to see a kind of a burst in fire activity in the grasses there. So we're going to continue to see this for the next couple of months. You'll notice there's the green area there in the Sierra. That's a below normal area of large fire potential, and that's due just to the heavier snowpack and the wetter fuels up at the higher elevations, generally above 8,000 feet or so. The Sierra foothills is where we're most concerned for this fire season as we head into the summer, with the more significant grass crop, along with the tree mortality that we have generally in the 3,000 to 6,000 foot elevation range. So now this year, more than any year really in the past 5 years, or over the past 5 years, we have now a significant grass crop that will allow fire to carry into the heavier fuels, like a lot of the tree mortality areas. So that's kind of our focus for our large fire potential for this summer. That's at least where we're most concerned for this summer. So let me back out of that, go back to my PowerPoint for a minute, and these are kind of old maps here, and we'll end with a summary sheet here. Let me bring this up. So just to summarize, I didn't talk about this too much, but we do have a significant grass crop with all the rainfall that we had this past winter. We've had, this is probably the most significant grass crop we've had in the last 5 years, which really kind of seems like an anomaly, but it's not. I think a lot of people have just been used to the limited rainfall and limited grass crop that we've had each spring and summer over the last 5 years. It kind of makes this one stand out. But prior to the drought, you know, this is kind of normal, a little bit more than normal, but not too far off. But anyway, we've seen already a burst in fire activity among the light flashy fuels, and that's going to continue for the next couple months. I think things will kind of settle down a little bit as we get into the kind of the summer months here in terms of the grass fires. Most of the grass fires are not going to be a significant drain on regional resources, but they will require a high resource demand at the local level. Team deployments, I don't need to get into that too much, but they're generally not going to be likely with these kind of fires. These fires burn very fast, intense, but only for a couple of burning periods, so they don't last too long. The live fuel moisture, I didn't really show a graph of the live fuel moisture, but it's generally across much of California, it's above average for this time of the year, and it's likely going to stay above average. It's going to decline throughout the rest of the summer and into the fall, but it'll likely stay right around average throughout most of the fire season, which really means that most of our significant fire activity, apart from the grass fires, is going to be slow to develop, and which means we'll probably see those more significant fires in the heavier fuels developing later in July and August. But one of the things we're concerned about is the heavier fuel loading and the more decadent dead material that we have is going to result in some significant fires later in the season. And as Gina mentioned, the monsoon probably staying a little bit further to the east, which means we'll probably have a little less lightning activity than normal, but it's still a little too early to tell kind of how the monsoon's going to shape up. That's always a big wild card for us. And it just takes a small amount of lightning to really kind of change things dramatically for us. Deserts, as Gina mentioned also, we'll probably see more fire activity than normal just because we have more fuel loading out there. And then again, the combination of the significant grass crop with the tree mortality is going to be the focus for our fire activity this fire season. So anyway, there's my contact information. I appreciate the opportunity to get on the call here. Thank you, Amanda, for that. And I'm all done except for any questions that people might have. Thank you.
Great, thanks, Tom. At that time, it's a good changeover. We're going to take all questions. I think a bunch flooded in earlier on as well. Tom, I think there's one question that might relate to you in California was, how would the, quote, GINA analysis correlating drought to fire seasons in Nevada differ for California? A recent newspaper analysis came to the opposite conclusion for California. I think you hit on this a little bit, but it was still a question that came up.
Yeah, that is a good question, and to be honest with you, I haven't done a lot of research in that area. You know, to be quite honest with you, we were expecting a busy fire season 2-3 years ago, and because at that time we were a couple of years into the drought, particularly along the Central Coast, where we were seeing that D4 drought on the drought monitor, for an extended period of time over a large area, and it had been quiet there until last year, and the Central Coast really blew up with a lot of significant fire activity. And my gut feeling is, because I've been here and doing fire weather for over 20 years in California, and just we haven't seen a drought this severe in quite some time. But my feeling is that I think the drought finally caught up with us last year, because prior to that, we had our fire seasons were pretty quiet in California. until last year. And like I say, I think kind of everything caught up with us. We were accumulating more and more decadent dead material just because of the stress from the drought, that the vegetation was stressed by the drought. You know, there's Gina said the same thing. You know, when we have a drought, everybody says it's going to be bad because everything's dry, and if we have a wet year like this year, you know, it's going to be bad because we have all this fuel. And you know, the thing about this year is we're not going to have the kind of fire season we had last year. It's going to be a quieter fire season. Yes, it's going to be busy initially with the grasses. Things will kind of settle down a little bit, and then we'll kind of get into our normal type of, you know, fire activity, which can be, you know, fairly busy, but that'll come a little bit later in the season. But, you know, people think that, oh, because we've had a wet year, it's going to be really bad, and that's not necessarily the case, and that's because of the different fuels that are out there, the live fuel moisture, the dead fuels, the grasses, they all play a big part. And if you just look at the grass alone, that's not enough to determine what our fire season is going to be like. So I don't know if that answered your question. I was kind of babbling a little bit, but.
Oh, that's great, Tom.
Does that help?
Yes.
Okay.
Okay, and then first I want to say thank you to all of our speakers for your great presentations. We do have some more questions, but I know we're running over much longer than usual, so I'm only going to take a couple more minutes after this to do questions. But I just want to remind everyone that the recording and slides from this webinar will be on drought.gov later this week, as well as the 2-page flyer summary. And our next webinar is scheduled for Monday, July 24th, and the registration's already open, and that should also come out in the post-webinar email. Here just to do a few more questions in the few minutes we have. I think some of these go back to Dave, if you're still there, from when you presented, including how do lingering groundwater concerns in California affect your overall drought assessment? And I think they might be referring to the drought monitor. I didn't know if you wanted to offer a few comments on that.
Yeah, sure. Yeah, that impacts, that's part of our assessment, and we do take into consideration those. At some point, you know, we've had a lot of discussion amongst the drought monitor authors, as well as larger group of people in the drought community and climate community in terms of groundwater situation, because some groundwater situations, like in the Central Valley of California, could take, you know, a decade or decades to recover. But in short, yeah, those areas in that you can see on the current drought monitor map that are still in D1 within California and Southern California and the southern and the central coasts, they are D1 in particular to the groundwater issues and reservoir issues there. So yes, they do play a role in our assessment.
This is a quick one, I think. If 2016 to 17 was the second wettest year in California, what year was number one, and do you know what margin that was by?
I don't know the exact margin, and it depends how you look at it. There's different, as I had mentioned earlier, and we were looking at some of the climatological rankings. There's different methodologies involved in looking at it in terms of the data sets that are being used. So I would say, you know, statewide, yeah, it's looking like it was the second wettest. I don't know exactly what the margin is. I think it's more useful probably to look at some of the divisional data to take a look at particular areas of the state that you're interested in. But overall, I would say the Central Sierra had a record year this year, definitely, in other parts of the Sierra as well.
And then I'll do this one as the last question. There's a few more questions, but I encourage the question askers to send them to me or contact the presenters. But the last one was just, when you say above average for various indices such as temperature, what is the baseline you're using to calculate your average?
This is Dave, is this for me?
Yeah, it came up during your session, I think mostly is when the question popped in, if you want to answer.
Yeah, I mean, it depends on, again, the data product we're looking at. But say, for example, the ones that I was looking at, they were using PRISM data. So the normals are based on 1981 to 2010. So, you know, how much of a departure from the mean from that period of time is how they're calculated.
Okay. Great, thank you. And thanks everyone for sticking around. I know we were a little bit longer than usual, but I think it was great information, especially with the coming season and the interesting results, for example, that Gina and Tom were talking about with fuel loads this year and things like that. With that, I'll go ahead and close the webinar and thank everyone for joining us. And I encourage you to please fill out the survey after the webinar. That's sort of how we're getting these ideas for topics and what to cover every 2 months. And wildfire was a big one that we heard about last time. So I encourage you to fill that as well. So thanks.